So task 2 requires you to demonstrate your knowledge of testing and debugging code. To do this, you're given a piece of non-functioning code, a test plan template in Word, and the requirements of the program in the set task brief. You're required to debug and test the code and implement a functioning solution. You've also got to effectively document the testing and debugging process. This is a copy of the test plan that you're given. You need to have the description of the test data that you're going to use, the expected outcome, what you expect to happen, the actual outcome, what actually happens, and then in comments and intended actions in that box you need to describe what it is that you need to do to fix the code if you found an error. So this is our code for the sample assessment material, and you're given it as a text file, so basically you need to convert that into a PY file so you can run it. We can immediately see at the moment that there is an error here on lines 10 and 11 because those are indented and they shouldn't be. So that's the first thing that we're going to fix, and of course we're going to document that in our test plan. So your first test that you need to record is always going to be check if the program runs. You expect it to run, which of course it doesn't in this case because of those errors that I pointed out earlier. So there are indentation errors on lines 10 and 11. These are indented when they should not be. So obviously this has now been corrected. So then we need to run that test again. We expect that the program will run now. So let's take a look at that. Okay, so we've just fixed those errors and we can see that now changes from red to orange. That's because there's still an error down there, but we're going to ignore that for now. All we need to see is if this program runs. So if we press F5 to run the program, then we can see that it does run and it asks for your name. So we just need to record that in the test log just to say what happened. Okay, so we've just completed that now. So program runs and it prompts for the name to be entered. No further action is needed regarding that. So we need to start running the test data now to enter the name and see what other prompts it gives us, and that is what we're going to record next. So this program needs to accept some details from the client. Okay, so it's going to take user details, which is what it's asking for there. Then it's going to let them pick a type of investment, and it should forecast the investment over 10 years over a different return rates. That's what it says in the set task brief. So make sure you understand what it is that the program needs to do. Okay, so if we start off just entering a name, 7890. There we go. Okay, how much would you like to invest per month? Let's go for £100. I'm going to press 1, and then we get an error. Okay, so we can record the test data that we've used and then what type of error we've got here. So if we look for the line where we're actually being accepting the string when it should actually be a float, which will be up here. Okay, there it is. And basically we just convert that into a float instead of a string, and that will fix the error. But let's record our test data first, so keep recording it as we're going along, what we're doing, and that's what gets you the marks for this task. Okay, so we have recorded this in our test log. So our test was actually to check if user details can be entered. So we entered some details and we wanted to invest £100 per month, and then we typed option 1. What we expected was the program asked the user to select the type of investment, and then obviously that's calculated. But what actually happened was user details could be entered, but when option 1 was selected, the program throws the type error on line 50. In the comments and intended actions section, we can write why that is. That's because the investment amount entered is entered as a string, because import always returns a string, when it should actually be a float, which is the decimal data type for money. This input happens on line 21, where the input needs to be cast as a float. And then in there, we've just put a screenshot of our fix that we have done in the code. So now we need to run that test again, and does it accept this input now? So description of our test, we are checking if the investment sum is now accepted as a number. Okay, so now we're running the program again. As you can see, we've entered the same test data as before. So now let's see what happens when we select option 1. Okay, so we're getting some output this time. It's not formatted to 2 decimal places, as you can see. That's one of the requirements in the set task brief, so we'll need to fix that at some point. Okay, so let me just show you my updated table so far. So that was the previous test that we did. So it calculates, it produces an output. We're not testing whether that's correct yet or not. What we are going to do instead is check if option 2 works, which is this. So we're just using the same data again. This time all we're going to do is change to option 2. We expect it to be calculated, but we know it won't be because we can see that there's clearly an error in there. So the actual outcome, we are going to record what VS Code tells us that error is. Okay, so let's press option 2. So we've put in the same test data as we did before. We're just going to press option 2 and there it is. Okay, so name error. That's because we can clearly see that that's wrong, because if we look down here, it's called stocks main. So basically what we need to do is put an S in there and it should fix it. So we just need to record that in our test log. Okay, so there we go. We'll just record that. So there was a name error on line 43. The function had basically the wrong spelling, so we just changed that, and then we've got a little screenshot of our fix in there. Okay, so we're going to repeat that test again. So check if stock investment is calculated after the fix. Use the same test data. We expect the same result. Let's run it again and see what happens. Okay, so we've just entered the same test data in there. We'd press option 2, and this time we get some output. Okay, so we can just record that in our actual outcome box. So it calculates the investment and produces an output. So we have fixed that so far. Okay, so for our next test, let's have a look at this output in more detail. So first of all, one of the requirements is to have this to 2 decimal places. So we'll have a look at where this is being output in our code, and we're going to use the round function because we're talking about money, finance, so the round function would make more sense than just printing it out as an F string, because it's really important to have it rounded up for this particular scenario. So let's fix that first, and then we'll see if it's calculating our investment properly. So let's inspect this code in some more detail. So if we look at savings min, then this is where it displays the values. And if we look at savings max, there's also some values displayed in there. Now if we have a look at this on line 97, we've got some kind of useless code in there. So we've got this number 2, which is not really doing anything useful. I think they've given you that as a hint to use the round function on this. So basically, if we change that to round, then it gives us to a purpose because we're rounding it to 2 decimal places. We need to do that for each time we're displaying some monetary amount. So we need to do it there, there, and then in this function as well. Okay, so we've just recorded that we're going to try and fix this and fix our rounding errors, basically. I've put down that we've done the savings min and savings max functions, and I've just given an example of what we've done to change that. We then need to run another test to see if that works. Okay, so there we go. We've just put in exactly the same test data, and we can now see that the output is all to 2 decimal places. Okay, so that's for the savings option. We need to do the same again for the stocks option, and then we need to do the same fixes again, and we need to record that in the test plan. So basically we've fixed all that, and all we've done is put some examples in of the fix that we've done and the output just to prove that it works. And then again for the stocks option, that's an example of the fix that we did, and that's an example of the output just to prove that it works. Okay, now that we've got a nicely formatted output, we can have a look at other problems that might occur. So this is for the stocks one, and as we can see here, total tax due is 0, and it says that for all of those. That doesn't seem right, because I'm sure we should be paying tax at some point. So we can go and investigate the code and find out where the tax is being calculated and what might be wrong with that. Okay, so we'll start off with stocks min function. Here we've got tax payable. Stocks min dot total multiplied by tax rate. Post tax is stock min dot total minus tax payable. Okay, so that's stocks min. Now let's go to stocks max. And this says stocks min again. Should that actually say stocks max? So if we change that, we can run that again, and then we'll see if that actually makes a difference. But in the meantime, we do need to record that as a test in our test log. Okay, so this is how it's recorded in the test log. So calculating the amount of tax payable in the stocks option. That's our test data. Program should display the amount of tax to be paid each year, but it doesn't. It displays it as 00. And in here, we've just recorded our fix. Okay, so we found out that it said stocks min total. Okay, so the wrong variable was being used. So we have changed it. And now what we're going to do is a retest using the same test data. And now we'll see what happens. Okay, so we've run it again after that fix, put in exactly the same test data. And as we can see, total tax still says 00. So what we're going to do now is we're going to try some different test data because we need to see if this fix has actually worked. So basically we're just going to try the same test again, but with some different test data. This time we're going to put 1,000 in. Okay, so we've put some of our test data in there. We've put 1,000 in there, and we're going to press option 2. And there we see it has calculated some tax. Now what we need to see if it has calculated the minimum and maximum values correctly. So now what we're going to do is some boundary testing. A lot of students actually miss this bit out. You will be given boundaries of certain things in the set task brief. This one, you can only have the savings plan if your yearly investment is under £20,000. So what we're going to do is we're going to do a test. We're going to say we want to put £2,000 a month in, press option 1. And what should happen is, because the yearly investment is over £20,000, the program should detect over limit and ask for a lower amount. So let's see if that works. Okay, so there we go. Started putting the test data in there. How much we want to invest? 2,000. And if we press option 1, it does actually reject it. There you go. That's the error message. How much would you like to invest per month? Obviously, we need to put in less than that. So if we put in less than that, it should carry on and produce the output. So in the test log, we can just record that the program did as we expected. It works as expected. We don't need to do anything else. So we can then go on to do another test. Okay, so to test this next part, we're going to test forecast calculations for the saving plan. Our monthly investment amount is going to be £100, and we expect it to display the correct minimum returns, which is 1.2%, and the correct maximum returns, which is 2.4%, after 1, 5, and 10 years. Okay, so what I'm essentially doing is checking if this for loop and if statement works. So I've put in this line of code here, which is going to print this out for each iteration of the loop. Okay, so the loop counter is I. And it's going to print out whatever is being stored in that variable rounded to decimal places. So this is the output. Okay, so year 0, which is actually year 1, that should be our minimum returns. This would be year 2, but this has now printed out, which is very strange. So this is actually year 2 that is printing out instead of year 1. The problem we can see is on this line, because the arguments for this if statement are actually wrong. If you look down here, we can see the pattern. Okay, so this is savings max for I is 0, 4, and 9, and that's also repeated further down there for the stocks one. So I think we can safely say that is the problem. So if we change that and then log that in our test log. Okay, so this is the test log again. So the program prints out the incorrect forecasts, and we're just explaining why, because this if statement is basically wrong. So I starts at 0 in the for loop, so year 1 is actually I equals 0. Year 5 will be I equals 4, and year 10 will be I equals 9. So we've just changed that, and also don't forget to add 1 to that, because that prints out the year. We don't want it to print year 0, we want it to print year 1. So we're going to try that test again. So remember to record that in the test log and run it again. Okay, so we've removed that print statement because we don't need that anymore. And we've put the test data in again, run the same test, and we can now see that that is right. So we just record that in the test log. The next one we're going to test is another boundary test. We want to see if a monthly investment amount of £1,666.66p, we want to see if that is accepted within that boundary. So I've run the program and I've put the test data in, and you can see it's quite happy with that, and it's done the forecasts for the savings plan with that amount of money, so that works fine. Okay, now we have to check if the managed stocks work. So that is our test data that we're going to use. That's what we expect to happen. So let's see what actually happens and if this works as expected. Okay, so I've put that test data in there, and this is the output that is displayed. As you can see, that seems to work fine. Okay, so we've got some other tests to show the fee calculations. They actually all work. We don't need to fix any of that. So that's actually fine to just put those in like that. The next one we need to test is a tax calculation for managed stocks. First one, we need to test that no tax is applied when the stock's value is below £12,000. Okay, again here I've used two print statements. So for each iteration of the loop, we can see what values are being stored in these variables. So this is the printout. So this is for the lowest rate of return. So we start at 0 there, so tax rate is at 0 because the investment is worth less than 12,000, and then this is the printout for each year. As we can see, as soon as it increases over £12,000, then we start to pay the tax rate. Have a look at this code though. In the set task brief, it actually says the 10% tax is on profits above £12,000. But if we go back to the code, it actually says greater than or equal to £12,000, which isn't right. Now, I think that's not very fair actually, because you can't actually test that, because the 12,000 in the context of this program doesn't divide equally by 12. So I think it's 833,333. So you can't put that in because it just doesn't work. But the logic is wrong, and that does need correction. Again, the same for that one as well. But there's no way to test that, so I think that's a little bit unfair. But we can see that it does actually work, so we can say that it works. But also put a note in to say that you have corrected that logic because it's wrong according to the client requirements. Okay, so we've just explained that it did work technically, and then we've just explained a bit about the logic being incorrect, and we've shown the fix for it. The incorrect logic also appears in the stocks max function, so you need to change that as well. So now we can go on to check if 10% tax and 20% tax is also applied. So basically we can just leave our print statements in there and just check that it is applied. We can also put the print statements in the max function if we want to double check that it works in there as well. Okay, now we're going to have a look for some input validation checks which are not present because they're not in the code. So if we have an empty input for name, then the program should prompt the user to re-enter the name, but it doesn't, it just continues. So we've put a note in here, implement error handling for common user errors. You don't have to implement that yourself. That's not actually part of this task, but we're just putting that in just to prove that we know about this sort of thing. So let's try and put a non-numeric value in amount to invest, and we'll see what happens. So there you go. I've skipped all of that. We don't have to put anything in. I'm presuming that's just so you can get through testing quicker. You don't have to keep entering it. But anyway, let's put ABC in there, and there we go. We've thrown an exception value error. There's no error handling again present, so we can just put a note on to say basically handle those errors. Okay, let's do another check. This time we're going to see if it will accept a negative number. Okay, so this time we'll put in minus 100, and it accepts it. Out of interest, what happens? There we go. Clearly it shouldn't be doing that. So again, input validation checks are required. So I've just done some stuff about input validation checks there. You might get code which has this implemented, so obviously you would need to check that and you would get some different results. I've noticed this quite a few times, so I've put down a note to the coder. There's not errors, but there's a few typos in printed text. I've actually noticed that in some of the actual exam materials as well. So, for example, they've written performance, also correcting word there, for performance instead of performance, and It says it's got an extra E in enter or something instead of enter. Now these don't crash the program, but they are unprofessional, so we've just put a little note in, because if you were testing this in real life and you notice those spelling errors, you will tell the coder. So we've popped that in there just to keep it nice and professional.